Hi everyone. Let us continue next concept that is known as properties of an image formed by a plane mirror. Okay. To know the properties of an image formed by a plane mirror, here I consider one mirror which is placed vertically, that is M dash is a plane mirror, and I consider here there is a one object which is nothing but AB. AB is an object and height of that object is considered h0. H0 is the height of the object. Okay, here to find out the location of an image, we require two minimum incident rays so that we can get two minimum reflected rays. So to get those two reflected rays, I consider here 1 and 2 are the two incident rays from an object. From one point. Okay. So let us see, this is an incident ray and one more incident ray I consider like this. AO is one incident ray and AO dash is the another incident ray. So once the light rays are incidenting on any point on a surfaces, automatically it will reflect back. But our question is, what is the path of the reflection ray? So to find out the path of the reflected ray, you must know the normal at that point. Let's say, for example, this is the first incident ray. So this is incidenting on the mirror normally. Okay, I need to find out the direction of the reflected ray also. To measure that direction of the reflected ray, you know the normal. So if I draw the normal which is along the incident ray only, why? Because normal is always perpendicular to the mirror or perpendicular to the point. So now this is the incident ray, and here if you observe, in this case incident angle I is equal to 0. Why? Because the angle between the normal and the incident ray is 0 degrees. Similarly, when I is equal to 0, R must be 0. By using a law, angle I is equal to angle R. So you know that laws of reflection. By laws of reflection, we can tell that angle I is equal to angle R. As I is equal to 0, definitely R must be 0. So the reflected ray also be moves in the opposite path, means it retraces back. We can say that it retraces back. So this is the red mark is known as a reflected ray. Okay. So and another incident ray, if you observe, AO is the incident ray. So which is incidenting at a point O. Now we should know the reflected ray. To know the reflected ray, what we have to need? First we need a normal. So this one NO is the normal I have drawn at that point. Okay, now how much angle it can made here? I with the same angle the reflected ray will be pass. So that here also angle I is equal to angle R. For example, this second ray is incidenting with an angle of 30 degrees. Then reflected ray also will move with an angle of 30 degrees. Right? Because angle I is equal to angle R. Right? Now we got the two reflected rays. Okay, so where is the image will be formed? You know very well, image is nothing but the intersection of reflected rays or intersection of extended reflected rays. Okay, right. If you observe these two reflected rays, they won't meet anywhere. This is the one reflected ray, this is the another reflected ray. They won't meet anywhere. That means these are called as divergent rays. So the divergent rays never meet really at any point. So what we have to do to get the image, we have to extend these reflected rays in the opposite direction. Let us see. See here, if you extend these rays, this is the extension of the one reflected ray and this is the one more extension of the another reflected ray. So they are meeting at this point. This point is called as an image. This point is called as image. So here intersection of, we can say that intersection of extended reflected rays. Intersection of extended reflected rays. So intersection of extended reflected rays are called as a virtual image. Virtual image. Virtual image is nothing but intersection of extended reflected rays. Okay, now as you know that virtual image is always erect. Virtual image is always erect. Erect means it is a straight images. Straight image, right? And one more observation we can find out from this diagram, that is h naught is the height of the object. Let's say hi is the height of the image. In case of the plane mirror, the height of the image is always equal to the height of the object. See, hi is equal to h naught. For example, you are 5 feet high, your image is also 5 feet. That means object height is always equal to image height. Here we can say height of the image or size of the image. Like size of the image equal to size of the object. Okay, right. And one more thing, the distance between the mirror to the object is known as object distance. The distance between image to the mirror is called as image distance. In case of plane mirror, the object distance always equal to the image distance. The object distance is equal to the image distance in case of plane mirror. And last one more property, that is called lateral inversion. Lateral inversion means left side of an object is always equal to right side of the image. That means, for example, if you stand in front of a plane mirror, try to raise a right hand, but your image is appear to rise left hand. So that is called lateral inversion. For example, let's see here. Let's say this is a mirror. If you keep a letter B in front of a plane mirror, the image will be appears like this. Right? This type of property is called as lateral inversion. Lateral inversion. And we have other properties like magnification, everything. We will discuss in the next class. Okay.